Hello everyone. In this blog, I'm going to tell about Semaphore. So basically, Semaphore is a part of our operating system. So before going to the definition of Semaphore, I would like to brief you that what Semaphore is. So basically, Semaphore is a method or it is a tool which is used to prevent race condition. So it means that when we synchronize the process or if we run multiple processes at a time and specific and especially the cooperative process, which means that the code which will be in common to every process, which is common. If we run these many processes at a time, there may occur the race condition. If the race condition occurred, there may be chance of loss of data, deadlock, or leads to other problems. So, to remove the race condition or to prevent the race condition, there is a method known as semaphore. So now we are going to discuss what semaphore is. So I'm going to discuss the definition first. So basically, a semaphore is an integer valued object. It means that it is an integer value object manipulated by the kernel that has the following atomic operation defined on it. So the operations which is defined is that initialization of the semaphore to a non-negative value. A p named as p by this the operation that decrements the value of the semaphore p. If the value of the semaphore is less than 0 after decrementing its value, the process that did the p goes to sleep. A v operation that increments the value of the semaphore. If the value of the semaphore becomes greater than or equal to 0 as a result, one process that had been sleeping as a result of p operation wakes up. A conditional p operation, abbreviated CP, that determines the value of the semaphore and returns to indication of true. If its value is greater than 0, if the value of the semaphore is less than or equal to 0, the value of the semaphore is unchanged and return value is false. So as we went through the definition, so I'm going to discuss about the definition. So in my point, a semaphore is an integer variable which is used in mutual exclusive manner by various concurrent cooperative process in order to achieve synchronization. As it is an integer variable, the value which is present in variable will help to mutual exclusive way. We can run multiple number of process and intermittently we have to achieve the synchronization. So as our definition tells us that semaphore contains an integer value which helps us to take place the mutual exclusion and can make multiple number of processes at a time, and ultimately we have to achieve synchronization. So now I'm going to discuss about the type of semaphore. Basically, semaphore are two types. First one is the counting semaphore, or the first one is the binary semaphore, and second one is the counting semaphore. So binary semaphore, this is also known as mutex lock. It can have only two values, that is 0 and 1. Its value is initialized to 1. It is used to implement the solution of critical section problem with multiprocessors. Now coming to the counting semaphore, its value can range over an unrestricted domain. It is used to control access to resource at multiple instances. Basically, the counting semaphore lies between minus infinity to the plus infinity. Now, coming to the advantages of semaphore. Some of the advantages of semaphore are as follows. So, semaphores allows only one process in the critical section. They follow the mutual exclusion principle strictly and are much more efficient than other method of synchronization. This is no resources wastage because a busy waiting in semaphore as process time is not wasted unnecessarily to check if a condition is fulfilled to allow a process to access the critical section. Semaphore are implemented in the machine independent code of microkernel, so they are machine independent. Now coming to the disadvantages of semaphore. So some of the disadvantages of semaphore are complicated, so the weight of the signal operation must be implemented in a correct order to prevent deadlocks. Semaphore are impractical for large scale use as their use leads to loss of modality. This happens because the weight and signal operation prevent the creation of the structured layout for the system. Semaphore may lead to priority inversion where low priority processes may access the critical condition first and the high priority processes later. So we came across the advantages and disadvantages of the semaphore. So now I'm going to give a glance look so how a semaphore will be and what is P and what is V. So first look the two operations which can be accessed to change the value of the semaphore. Means the variable we have to change the value of the semaphore. So the P1, the P semaphore S, while S is equal to wait until S is 0. So S is equal to the what basically we call the P as down and the V as up. Down means now for a V semaphore, that is S is equal, so the V semaphore is up, as we know the V is up, so the V will be incrementing the semaphore value. The P, as we know, P we can call the synonym for P is down. So basically what it does is the P will be decreasing the value of the semaphore. Now some point regarding the P. So as I told you, P operation is also called as wait, sleep, or a down operation, and the V operation is also called as signal, wake up, or the up operation. Both operations are automatic, and semaphore S is always initialized to 1. Here, atomic means that variable on which read, modify, and update happens at the same time, moment with no pre-assumption. That is, in between read, modify, and update, no other operation is performed that may change the variable. The critical section is surrounded by both operations to implement the process of synchronization. The critical section of process P is in between P and V operation. So here is the process P. So here first we are going with there is a process which we call as P, and here is some code. So basically some code means here some code. After that P of S means which means down. So first the process will be down, and there will be a critical section in which what is critical section means in critical section we are going to store the processes. So V of S means down and the reminder section. So in other words we can call that there is a process P. So process P. So first we have to go with the entry code. Entry code. So basically in entry code we are going to have the P process. Next, coming to the critical section. After entry code, there will be a critical section. If the entry code allows the process to come inside the critical section, then the process will be executed inside the critical section. And after next to that, we are going to have the exit code. Basically the exit code means we are going to use the V algorithm. So now let us see how it implements in mutual exclusion. So as I told you, there will be two processes P and the semaphore S is initialized as 1. Now if suppose P1 enters in the critical section, then the value of semaphore becomes 0. How? So as we afterwards we are going to tell what is how to implement the P and the V. So first of all, basically this semaphore comes under the binary semaphore. So now suppose the P1 and P enters in the critical section, then the value of the semaphore S becomes 0. Now if P2 wants to enter it critical section, then it will wait until the process completes. That means until the S is greater than 0. That means that until the P1 process completes. This can only happen if the P1 finishes. As I told you that this can only happen if the P1 finishes in the critical section and calls V operation on the semaphore. So as I told you here, so in the critical section, if there is a process exists, after completion of the process, the process will execute the V operation. After the execution of V operation, automatically the S value will be incremented to 1. If the S, in binary semaphore, what is checks that after coming, it will check whether in the suspense list there will be a suspense block in which the process will be in the sleep mode. So basically from that process we have to extract that. This way mutual, so until the, as I told you, until the process P1 finishes critical section and calls V operation in semaphore. This way mutual execution is achieved. Look at the below image. So here is the image which we can clearly define that in the first state. So basically in the first state, so S is equal to 1. As I told you, S is equal to 1. So P1 is the P1 executing in non-critical condition. Okay. P2 will be the executing non-critical condition. So in the state 2, after, so basically the P1 will be entering to the, if S is equal to 1, the automatically the process will be executed successfully. So now coming to the state 2, now the S is 0. So now the P2 cannot come into the critical section as S is equal to 0. So it will be in the sleep mode. After completion of the P1 process, then we are going to when then the P1 process comes out and the S will be becoming 1, and it will wake up, and by using the P operation again we are going to wake up the process from the block list. So here is the implementation of the semaphore which is in C program. Now coming to the limitations. So one of the biggest limitation of the semaphore is priority inversion. So deadlock, suppose a process is trying to wake up another process which is not at sleep state, therefore a deadlock may block it indefinitely. The process system has to keep track of all calls or wait and signal of the semaphore. So these three will be the limitations of the semaphore. So now I'm going to tell the implementation of the counting semaphore. So as we know, the counting semaphore will be lying between minus infinity to plus infinity. So here, the implementation of the semaphore, now counting semaphore here, first of all, we are going to have the structure in this is a C program. So first we are going to have a structure and a queue of processes. So now, as we know, the first execution will be before going to the critical condition. Every semaphore means every process will be going with the P process. So at first P in the P process. So first after entering to the P process, it will check the semaphore value. So first the semaphore value will be decremented. After checking the semaphore value means if semaphore value is less than 0, if the semaphore is suppose we take S is equal to 4 or S is equal to 1. So suppose we are as it is a counting semaphore, so we can take S is equal to 2. So if S is equal to 2, so first what we will do. So I'm going to explain up here. So first initially S is equal to 2. So here, so initially S is equal to 2. Now it is going to decrement the S value. So here the S value will be becoming 1. So here the S value will be becoming 1, and it will check whether one is whether it will check 1 is less than 0. As it is not 0, so it will again the process will be successfully going to the critical section. After the critical section, again it will, after completing the process, again it will execute the V semaphore. So the same process will be occurred here. The wake up P means that the semaphore, the processes which is in the blocked state. So what the wake up process do is that when it will go to the block queue. It will go to the block queue. It follows the FIFO implementation, the first in first out one. So as the process will be in the block state, first it will be picking out the process, and the process will be wake up by this algorithm. And here completes my blog, and thank you.